quickly just give a disclaimer. Whatever we discuss, these are your own personal views. You are not representing any organization in any way.
Oh, yeah.
So
Thank you.
perfect. So I'll start with the first question. So according to me, it's more of a observation that I noticed that it feels like we are moving away from agents that just guess based on the probabilities towards agent that can actually traverse a map of facts. So from your vantage point at Meta, do you think that knowledge graphs are the key to solving the hallucination problem for enterprise level agents?
Oh, yeah. You mean through the agents, right?
Yeah.
Uh, yeah, I think a lot of work right now I'm working with through the agents. But
Mhm.
it has different kind of format, but they cover nearly all the aspect. I mean, smallest could be like create agenda, create like a calendar invite, create like a summary, doc summary, or like a data set summary. A bigger one could be do analysis. I could give a query like a SQL query or some kind of thing, and then give an example to it, and then let this agent basically to do the same thing, but for all the tasks in the similar way, like
Got
a
it.
batch
Got it.
processing.
And on the graph versus vector RAG, like most developers are currently stuck using simple vector RAG. In your experience building at scale, like in whenever we build at scale in Meta, you are very well averse of that. When does an agent need a knowledge graph instead of just a vector database? Like, is it primarily for multi-hop reasoning or for maintaining strict data relationships?
I think if for both actually. So original RAG basically we do the chunk, we generate embedding, we do the vector search, and then put the top k chunks into LLM, right? So we only do how similar they are, and then basically they could be KNN or something to find the nearest. K nearest neighbors or something, but it may miss some very important information, and
Right.
then it doesn't have this multi-hop like inference or something. Also, the context, it's like just a kind of piece of information, but a GraphRAG, basically, we have entities, we have the relationship. It can grab a lot of this kind of relationship. Like one project I have worked with before, I think GraphRAG is very good for recommendation system. So if we
Mhm.
want to recommend something, we want to know what, uh, like for example, the people is learning or using this tool, but we also want to do some advertising. We want to give some like ads about some other tool. So we need to know the relationship between that one to the current product. And maybe can give them recommendation and also like based on what they are looking at, and we can find some similar content that also need the relationship and entities. And so we have this query, we find the entity and then basically do some subgraph retrieval, and then give this kind of structure and the related context into LLM. Then we can, based on the graph relationship, we can do some like inference and generate answer will be more accurate than the information before.
Got it. Yeah, that makes sense. My next question is on the entity resolution. Like one of the hardest parts of knowledge graphs is entity resolution, making sure the AI knows Meta, the company, is the same entity across different data points. So how do you see AI agents helping to build the very graphs they use to reason?
I think it's important because if this entity resolution, if we cannot do well, that graph may be like a mess. For example, one company could become like a 5 nodes, and
Hmm.
then the relationship could be here and there. So will be these five different like name of this same company have a different relationship. And when we do this recommendation, we could find the wrong one and wrong trace, and it will be totally a mess. Actually, it
Right.
could be like much concept. And also this based on that, the reg maybe the search when we find the k-nearest neighbors or something, and then it can only get part of the information, not the whole information, because it can only find a part of related entity to it. And also like the agent memory can only save a part. So like maybe this user and user A, and then user like also A, but in a different format will be treated as different person. So yeah, this I think this is why it's very important.
Got it. Yeah. Uh, and some niche questions, like a couple of ones. So on topic, modeling to knowledge graph, your PhD work involved topic modeling, right? So do you see knowledge graphs as the evolution of topic modeling, like where we don't just find topics, but we define the exact logical relationships between them?
I think it's like I did a research before, so basically, uh, we use topic modeling from a lot of unstructured context. We can find what is the topic structure, and then we use it to build this knowledge graph, like a middleware or something. So it's like a topic modeling is like a knowledge graph construction, and then it's like a architecture generator. So we have maybe like a lot of context like paper, ticket stocks or logs, and then the topic modeling can help answer like what this content could be in the different like a topic clusters, like maybe topic A like LLM, RAG, retrieval, topic B maybe like system design, scalability, topic C authentication, security, like this kind of thing. And then because on like knowledge graph is usually there are a lot of entity, a lot of relationship. So topic modeling can help to basically do another entity, like entity level graph construction. So
Right.
like document we generate two topics, like use topic modeling could use LDA and MF. That's the popular ones. Like a bird topic I also use the right now also very popular, and maybe can use embedding clusters as well. So each doc will belong to some kind of topic, and then each topic may have some keywords, and then we can later map this topic to entities. So in each topic we can
Mhm.
extract this entity, like can call it like a entity in its extraction, NER, or like entity linking. Then we can like construct a knowledge graph. The nodes will be entities, and age will be the co occurrence and the semantic relationship. Then the topic can be the supernode. Topic can also be a node of the knowledge graph.
Got it. And one last question that's on the knowledge lab. Uh, like, what do you think? What is the number one mistake you see AI engineers make when they try to integrate structured data with unstructured models like LLM?
uh, structured data with unstructured. Can you give an example?
Yeah, so I'm trying to just, I mean, structured data could be knowledge graphs, and the unstructured models are LLMs.
Oh yeah, 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 that's right. So I think when we have this structured data, maybe like tabular data, and then combine with LLM, maybe like we use. So sometimes like we use these structured data like tabular data or just data, use them as text. So that could be one mistake. And then we use
Right.
this basically unstructured LLM to deal with them as text. And then, so for example, maybe my name's Xin, and with my age, my company, my role, and
Mhm.
I just basically give this whole tabular data and with many others, and give this data set as the text context to LLM. And or maybe like a different way, like use a SQL or like a graph query to make them into a prompt. Like here is the
Correct.
result, the first row, the second row, and then now LLM help me understand. Or maybe uh, let LLM to do some like a deterministic thing, like
Mhm.
you join the table together, you filter some condition, you duplicate something, or find some keys, or this could be like because it can hallucinate, it cannot make sure
Right.
to get the right answer.
Got it.